All right, good. Hello. If I have to tell you good morning, good afternoon, good evening to everybody of my WOC family. Yes, welcome back to one more session of your last minute revision, students. Yes, yesterday I have sent you part one topic that's nothing but part one. I have taught you completely expected questions in organic chemistry. So please check the playlist. Yesterday, organic chemistry, what are the expected questions for your term two I have sent. So today we are going to go into the term two, that is part two of your grade 12. Welcome students. So before I start, today what are we going to learn? Remember students, WOC has done 1600 plus videos for grades 10, grade 11th, grade 12th, JEE as well as NEET. So please watch, subscribe to the channel, and important thing, everything is quality based education here. So join, it's a free platform. Right, let us start off with the session. Nothing to worry. Before I start, yes, this is the topic. What are we going to do? Today we are going to completely solve. What is that? Short questions of D and F block elements. Okay, right. So here what I'll be doing, I'll be teaching you tricks how to answer. I'm going to also show you the complete flow chart of your D and F block. So basically, we are going to do D and F block elements one shot. Okay, one shot would be there in this one particular hour. So understand everything. I'll be teaching you the keywords as to how to write in the marking scheme. According to the marking scheme, how we are supposed to write. So let us start off with the session. Right. So first of all, important, as I said, for your term 2 syllabus, all the chapters, whatever are there, one shot videos are done from my end. So please check one shot videos, that too from line by line of NCERT. I took line by line of NCERT and I have done all the videos. So please go through all the videos which are kept in the playlist. Got it, students? Done. Right. Let us start. Before I start, let me check whether it is getting recorded or not, so that it will be a problem again. Okay, chal. Keep. Now, let us start off with the explanation carefully. Right. So before we start, this is the DNF block elements flow chart. Okay. So first important thing, see here. First, I have discussed about the occurrence. Okay. So in that particular complete D series, D block elements. So the most abundant element, the fourth abundant element is iron. Fifth is titanium, and technetium doesn't occur in nature. So these three things are the exceptions which you should learn. Apart from that, I have given the general electronic configuration from where to where the group D block starts, and what is the series and what is the configuration. So everything, and what is the important part in each period. So your flow charts is useful for your one shot. So I'm going to explain each and every question now in just 5 minutes. So note the flow chart completely in a notebook. The whole chapter is covered in this. After occurrence and introduction, next I have taken to physical properties. So you all know they are electropositive because they are metals, or because they are metals, they are malleable and ductile. At the same time, because they have lot of free electrons, they are good conductors of heat and electricity. And they are going to exist. Basically, transition metals react with oxygen. To prove that, manganese we have picked up, where manganese reacts with oxygen to form basic oxides, amphoteric oxides, and acidic. There is one question which is asked, why lower oxides are basic and higher oxides are acidic in nature? That question also we are going to discuss now. Yes. So in that, again, what are transition, what are covalent compounds? So please note this. Again, as I said, detailed explanation we are going to see. Detailed explanation of each question I'm going to explain in 5 minutes. Then after that, lanthanides. Where is the electron entering, what is electronic configuration, common oxidation state, and how does atomic radii decrease from lanthanum to lutetium due to lanthanide contraction, and difficult to separate because of lanthanide contraction. So I'm going to discuss that. Next, students, after that, general trends, atomic radius, all the trends I have listed out, 1, 2, 3, 4, 5 trends. Please learn this. After this, ionization enthalpy. What are required points in ionization enthalpy I have discussed. Why 5D series ionization enthalpy is more than 4D? Because of Z effective is more, nuclear charge is more. So I have discussed that. Gradually from there, melting and boiling point question, if anything is asked, which has low melting point, what is the reason? Why the melting point is basically high for D block elements or the transition elements because of strong metallic bonding. So everything I have discussed. After that, we'll go to oxidation state. So common oxidation states of what? Which orbitals are involved also. I have given 3 points in this. At the same time, when you're going to the magnetic property, we very well know magnetic property depends upon number of unpaired electrons. So unpaired electrons, if more number of unpaired electrons are there, then automatically you'll have that magnetism, that paramagnetism in that. So this is a formula to calculate, and which elements are diamagnetic also I have given here. Done, students. After that, gradually we have gone to the colored ions. Done. So in why transition elements are colored? Because of unpaired electrons. Perfect. If you have filled d orbitals, if there is unpaired electrons are absent, then the particular salts appear white in color. Got it? So everything is mentioned here. Then comes complex formations. We very well know D block elements are going to show variable oxidation states, right? Because of this, they tend to donate. When they tend to donate, they form complex salts. Complex compounds is what is the characteristic property of transition elements. That also I have taken an example. Then catalytic property, we very well know they have vacant d orbital. Done. Lot. And charge density also is more, so they provide large surface areas. They have very large surface area on the metal, so that's why iron acts as a catalyst, nickel acts as a catalyst, platinum, palladium. Okay, then if I have to take, okay, so cobalt also I can take, aluminium also I can take in certain cases. Yes, so like that, they act as catalysts because of what? More surface area. So this topic also I have taken. Please take it and note it. Then comes alloy. We very well know there are a lot of, basically the D block elements have active sites. So small atoms like carbon, nitrogen, hydrogen are going to add, you can add them. So what will happen in these interstitial sites, in the gaps? Because of this, yes, you will be getting a combination of interstitial compounds. Means small atoms are there inside this, and you will get the concept of interstitial. So I just gave you the summary, students. So completely the whole chapter would be there in that. So please note, before I start, remember, please watch one short video of D and F block elements. One shot. Again, I did line by line of NCRT. Line by line of NCRT is done. Sure. Now I'm going to show you as to how to write your answers. As to how to write your answers, basically like according to the board answer key. Let's start. The first question, one word answers. First we will go with 1 mark questions, then we'll go to 2, then I'll take you to 3, then I'll take you to 5. Okay, so let's start. So zinc, cadmium, mercury are not treated as true transition elements. Why? Only one sentence you have to write, students. Why? If they are not treated means one keyword which you should write is because. Because is like this for me. Don't write in the exam like that. Yes, because they have completely filled shell. Completely filled d orbitals. So completely filled d orbitals they have d10 configuration. That is the reason if something has d10 configuration, in which one? In their stable as well as stable ground state, and in the stable oxidation state also. So basically whichever has a d10 configuration, they are considered as not transition elements. Suppose if you have d1, d2, d3 like that till unpaired electrons, if they are there, if the incoming electron is entering into d orbital, then I call it as d block element. Otherwise it is not d block or transition element. Rather, if it is not having, I call them as non-transition elements. Got it? So write this, because they are completely filled d10 configuration in the stable and ground, they are not transition elements. Not transition elements. Easy, students. You can directly write this answer in the exam. Next question. Copper, silver are transition elements, although they have completely filled. Oh, now you just now said. Problem here is copper accepted, silver accepted. But remember, copper is stable in Cu plus 2 state. Silver is stable in Ag plus 2 state. Both of them, when I check the configuration, general configuration is N-1 D9 4S0. Now you only observe here in D9 you have unpaired electrons. Correct na? 1, 2, 3, 4, 5, 6, 7, 8, 9. There is unpaired electron. Because of this unpaired electron or incoming electron, whatever is there, unpaired electron is there. Because of this, this is considered as transition element. What is, students? Transition element. Perfect. Next question. Why are some d block elements have irregular or exceptional electronic configuration? Why? There is lot of variation. It will start from +2, it will +1 also, rather +2 to +8. We have lot of variation of oxidation states. What is the reason? Yes, students, the reason is important. Write the answer like this. If they give you this question, write due to very small difference between which state? Between n-1d and ns subshells. This is the reason you have both. The difference is very less. That's why it can pull out electrons from here. It can also pull out from electrons from here and show so many oxidation states. Easy answer. Next question. Atomic size does not change appreciably in a row of transition metals. Why? Why? So, remember, atomic size does not change appreciably in a row of transition metals. Why? Means, careful, when I go check the transition elements from left to right, that is from scandium till zinc, that is your right. What is happening, students? In this, basically, you are going to have, check, you are going to add electron into the same d orbital. Perfect. So the same d orbital you are adding. Add, first you're adding d1, again d2, then d3, then d4, then d5, then again you're adding to the same d1 again, that is d6, then d7, then d8, then d9 and d10. So your pairing happens here. Correct. When pairing happens, the point number 1 is, yes, electron is adding to the same shell and d orbital has poor shielding effect. Correct na? It has very poor shielding effect. So when it is having poor shielding effect, what is going to happen? Outer electron, whatever is there, is going to experience what? Z effective. What is Z effective? It is nothing but nuclear charge. This nuclear charge, what happens? It starts increasing much. Yes, when it starts increasing much, what is going to happen, students? Atomic as well as ionic size. It pulls the electrons or the orbital outside one inside. Na? So atomic as well as ionic size remains same. It remains same. Remember that. So you can write these 3 points perfectly. Okay, so you can start your answer. The d electron enters into same orbit, enters into same orbit, same things. Okay, it enters, keeps entering into the same, so size from left to right decreases. Next question. Transition elements have variable oxidation states. Why? Just now we have answered this question now. Why variable oxidation state? Yes, clear just now. Almost. It's just, I said, na, energy difference between both of them. Energy difference between. So what can I write? n-1d and ns subshell. ns subshell. So what is happening here? ns subshell electrons. So the difference between ns and n-1d and ns, energy level gap is very less. Gap is small. So when the energy level gap is small, automatically I can pull out electron from ns, I can pull out electron from n-1d. So both, that is this is first point, second point, both n-1d and ns take part in bonding. Okay, students, take part in bonding. This is fine, right? So both of them will take part in bonding. That's why you have variable oxidation states. Next question. Transition metals have high melting point and boiling point. Why? Okay, done. Now, when they ask you melting point and boiling point, just start your answer with large number of unpaired electrons. This is the first keyword, number of unpaired electrons. So when you have large number of unpaired electrons, yes, where taking part. They are taking part in and bonding. Taking part in. So large number of unpaired electrons are taking part in bonding. It means what will happen because of this? Metallic bonds, more are adding, more are forming a bond. So it will form strong. I will write form strong metallic bonding. Okay. So if metallic bonding is strong, what is going to happen, students? Hence, MP and BP would be MP and BP would be R. Because I have to break that strong metallic bonding. Na? So write 3 points, you'll get full marks. Next question. Transition metals have high enthalpy of atomization. Why? What is atomization? Energy required to break. Correct. So that means you're breaking the atoms. Means atoms are indivisible, I understand. Molecule, you're trying to break it into atoms. Atomization means converting the molecules into atoms. So what is happening here? Why? Remember, point number 1 is there are large number of unpaired electrons. Correct now? From D1 to D8, unpaired electrons are there. So these unpaired electrons, what do they do? Same, almost it is the same reason, students, like almost similar. So atomization, so large number of unpaired electrons are there. So automatically what will happen? These take part in bonding. Take part in bonding. Which bonding? Metallic bonding. So when they take part in metallic bonding, what will happen to the ionization enthalpy? Ionization enthalpy increases. So they are taking part in bonding means what will happen? The metallic bond is strong. When the metallic bond is strong, what will happen, students? You have to apply more enthalpy of atomization is more. Correct now? Because the bond is very strong. You have to apply more energy to break the molecule into atoms. See? Next question. Transition elements show catalytic property. Reason. Same story. Almost similar answer. Yes, catalytic property means what? First, D block elements form variable oxidation state. Lot of different oxidation states are there. So when they form variable oxidation state, they can form intermediates. Correct. Intermediate means basically they are going to have like D1 configuration, D2 configuration, D3 like that, half filled, full filled like that. So when they form intermediate, they have, because of this, they provide large surface area. Large surface area is present where? In metal. When large surface area is present in metal, what is going to happen, students? They act as catalysts. That's all. So don't write a big story, just write the required thing and come out. Next question. Transition metals and their salts are generally colored. Why? Yes. Yes. Remember. Why are they colored? First important point, start your answer. They have partially filled. This is very important. Start your answer like partially filled D subshell. This is the first thing. Okay. Because of this partially filled D subshell, what are there? Unpaired electrons are available. Okay, unpaired electrons are available. This unpaired electrons, what will they do? They will undergo DD transition. Correct? They will undergo DD transition. Perfect. When they undergo DD transition, what is going to absorb? They absorb radiations. From where they absorb radiations? They will absorb radiations from visible spectrum. Am I right, students? Visible region. Okay. Done. And what do they do during this process? They absorb certain frequency and they are going to transmit complementary colors. They're going to transmit complementary colors. That's all. So all your points you'll be getting full mark in this. Complete mark. Right. Next question. Why transition metal form coordination compounds? Nothing. Yes, there are large vacant orbitals. Correct, students? There are vacant orbitals are there. Where are the vacant orbitals? Large vacant orbitals are available. Where are they available? In which? N-1D available. NS available. NP subshells are available. So when so many vacant orbitals are available, what do? They try to accept electrons. From where? From ligands. Correctness, students. So you very well know ligands donate, metals try to accept, and they form complexes. Done. This is the reason. Next, transition metals form alloys. Why do they form alloys, students? You only tell me. So, alloys. Just now I said it is a combination of two or more atoms. So what happens? They have transition metals have. I'll write here. For this in alloy formation, I'll write here. What is going to happen, students? You only tell me. In the particular thing, in the particular transition elements, they have like small size atoms, means they have comparable atom size pores, correct? So d block elements, they have comparable atomic size where small atoms like atoms like carbon, hydrogen, oxygen, nitrogen, I can fit them in the lattice, correct? They can fit in this. So when they fit into the lattices, what is going to happen, students? They form alloys. This is transition elements is one, interstitial compounds also same answer you can write. So here, this same answer for alloys, you can, instead of for alloys, when you write, you're going to write mixture of metals. Here you're going to add in the sites, and small atoms, when you write, you can write this for interstitial compounds. Same answer, right? For interstitial compounds, talking in terms of carbon, hydrogen, oxygen, nitrogen. For metals, you're going to add this. So alloy and interstitial compounds, same concept. Done. Next, cadmium and mercury have low boiling points. Why? Okay, one more question. Why do they have a low boiling points and mercury is a liquid? Tell me, students. Yes. So in cadmium and mercury, D10 configuration is there, fully filled. Yes. So what will happen? What will happen? The metallic bonding, or no electrons are there, everything is filled now. When all are filled, the d orbitals and nothing will participate. No, nothing will participate. So no metal bonding formed. So when there's no metal bonding formed, it will have low BP. But in this case, in case of mercury, size is large. So automatically, I will have gaps, and it will be a liquid. And students, easy. We go through the question again and done. Next question. Transition metals and many of their compounds show paramagnetic behavior. Okay. So when they give you paramagnetic question, don't write a big story. Write simple. Write only one word. That is nothing but because of unpaired electrons. Because more of unpaired electrons, more of paramagnetic nature. Next, D1 configuration is very unstable in ions. Why? Okay, D1 configuration. Why it is unstable? Remember, students, after you give, basically they lose one electron, they become a more stable, na? Correct. Because one electron, if they lose, they get inert gas configuration. Yes, correct. So if they're going to ask you, D1 configuration is very unstable. So D1 configuration, see here, it will lose one electron and it will reach inert gas configuration. So what is that? By losing one electron, they will become extra stable. Write this one simple word and it is good. Next. Chromium plus 2 is strongly reducing while Mn plus 3 is strongly oxidizing. Now, do I have place in the next page? I don't have place, so just see. I'll just write for you. Check. Chromium plus 2, I'll just make it simple. Careful, students. Cr plus 2 has, after losing electrons, it has D4 configuration. Correct? What does it do? It will donate one electron and it will become Cr plus 3. Now the configuration is D3. So this is which one? Stable T2G set. half filled enough. This is very, very stable. Done. Next, in the second case, Mn plus 3. Mn plus 3, if I have to check D4 configuration, it will take one electron and it will become Mn plus 2 and get D5 configuration. D5. You only see, students, D5. Check. Here, by losing one electron, it is becoming stable. By gaining one electron, it is becoming stable. You only tell me something is losing electron, so it is a reducing agent. If something is gaining electrons, it is an oxidizing agent. Why they are doing? Both are doing for getting stability. Got it, students? Easy? Yes. So question 1, question 2, question 3 discussed. Next question. Cobalt is stable in aqueous solution, but in presence of complexing agents, it gets oxidized. Why? Okay. Nothing, students. So basically, cobalt 2 is very stable, right? Stable. Where it is stable in aqueous. That is what they gave me. Aqueous solution, done. Now, what will happen? It is trying to form, right? When it to oxidation state to oxidation state, normally what happens? Cobalt oxidation number is what? Configuration is argon 3d7 4s2. This is the, what will it do? It will lose 2 electrons and become argon 3d7 4s0. Done. Now slowly argon loses one more electron. Yes, from plus 2 it will become plus 3. Let us check. Now what is the configuration? Argon 3d6 4s2. Now you only tell me. Here in 3d6 you have 1 2 3 4 1 2 3 4 5 6. See here, so many are empty, so it is going to start forming complexes. With this empty orbital, it starts forming complexes. What it means? So cobalt is going to have so many empty orbitals. That's why it will prefer losing one more electron and create empty orbitals. And once they form complexes, they'll become stable, right? They will form stable compounds. So that's why Cu plus 2 is stable in aqueous, but in the presence of complexing agent, it gets oxidized because it is going to have empty orbital and accept the electrons rather, and form complexes, finally form a stable compound. Easy, students? Very easy. And next question. Mn plus 2 compounds are more stable than Fe plus 2. Why? One simple answer. Mn plus 2 has 3d5 configuration, which is half filled. Easy. Half filled means most stable. Take this Fe plus 2. Fe plus 2, when I have to check. Yes, you only tell me in the comment section what is the configuration of Fe plus 2. Tell me in the comment section. I'll be waiting. Tell me in the comment section. So, what is the answer? So, because it is losing 2 electrons, it is becoming 3d5 and half. Now, what is this configuration? Why it is not stable? I'll be waiting for your answer. Please let me. Comment will be pinned. Thank you. Fe plus 3 is stable compared to Fe plus 2. Same story. Yes. So, remember, Fe plus 3 has, I already given the answer. Fe plus 3 after the losing means basically from Fe, after losing 3 electrons, it has become Fe plus 3, whose configuration is 3d5 4s0. Done. Suppose if it is losing one more electron from here, it will become Fe plus 2. It is going to become 3d4 4s0. So this one, this is less stable. Less stable. This is half filled, no? This is half filled. Half filled. Correct, students? So because it is half filled, it is more stable. So what is the comparison? Fe plus 3 is more stable than Fe plus 2. Done. Next question. Transition metals exhibit highest oxidation states in oxides and fluorides. What is the reason? Simple, students. When I take oxygen, when I take fluorine, the electronegativity difference is very small. The electronegativity difference, basically small size, high electronegativity of oxygen, difference is very less. Difference is less, and important thing is both oxygen and fluorine, they have small sizes. Small size. Third important thing, similarity between both is oxygen and fluorine have, important thing, high electronegativity. Same thing which I have written. So because of this, what is happening, students? What will happen? Whatever transition metals are there. So transition metals like Mn2O7, they form compounds with oxygen. Yes, Fe2O3 max, like that. Okay, SF6, so not here there is sulfur. So basically the molecules like anything AgF, this is one. So they try to form more compounds with this. Why? Because both have electronegative difference less, small size, high electronegative, and what is the main important thing, oxygen and fluorine, they can oxidize metals to highest oxidation state. They can oxidize metals to highest oxidation state. This is the main reason, students. Okay, that is the reason you can write. Next question, 2 marks questions. Let us start off with 2 marks. Done. So the highest oxidation state of transition metal is exhibited in oxo anions, that is your oxygen. This is the data given to you. Okay, they have given the electrode potentials. Explain the irregularity in the above results. What is it? So always remember, students, whenever you're writing a question on electrode potential, remember electrode potential depends upon factors. What factors? It will depend upon ionization enthalpy. It is going to depend upon hydration enthalpy. It will depend upon basically like atomization, enthalpy of atomization. So always talk in terms of these factors. So how am I going to write? See here, I will write the answer like this. I will write E naught m plus 2 by m, electrode potential values of these are not regular. I'll start my answer because, right, what is the concept? Always talk in terms of ionization enthalpy. One more thing, sublimation also will work, students, in this. Sublimation enthalpy also you can talk. So write down the answer like this, because irregularity in ionization 1 in ionization 1 enthalpy H1 plus H2. This is a lot of variation in these two. There is irregularity in sublimation enthalpies. Sublimation enthalpies. This is one more when I compare the table. Don't remember the table, but this is enough. Yes, and because of this, these two factors, we observe that, see here, where is the variation more observed? Variation, like not less observed, rather, in case of vanadium and in case of manganese. Done. So these two, both the ionization enthalpy and sublimation enthalpy are less in manganese and vanadium. That's why the electrode potential values are also not much variant. Just the electrode potential value, you're showing it as minus 1.18. Same for both. Write your answer like this and finish. Then next question. Why is E naught value for Mn plus 3 and Mn plus 2 couple more positive than that of Cr plus 2 and Cr plus 3 and Fe plus 2 and F plus 2? Write like this. See here, students. Mn plus 2 by Mn plus 3 by Mn plus 2. Done. Next, Cr plus 3 by Cr plus 2. It is going. Then Fe plus 3 by Fe plus 2. Now you only tell me. In the manganese, when I take, yes, from where to where it is going, students? By losing one electron. It is going from 3d4 to 3d5. Okay, this is what? This is stable. Next, chromium, by losing one electron, where is it going? It is going from 3d3 to 3d4. Got it? See, this is stable. This is stable. This is not stable. Then iron. Iron, by gaining one electron, it is taking one electron, it is going like it is undergoes a change outer electronic configuration from 3d5 to 3d6. 3d5. So this is stable. This is unstable. This is stable. This is unstable. Now you only tell me, student, you tell me. So this is going from D3 to D4 unstable, Fe3 to Fe4 unstable. That's why, because the configurations are not stable. Remember, E0 values are very much more positive. Means because their E0 values are lower. Correct. Why E0 values are lower means they are trying to go to the unstable configuration. Done. So E0 value depends upon their configuration. Like, this is the question. Then okay, this is done. This is a blank page which I have already written. Next question. In the series scandium Z is equal to 1, zinc the Z is equal to 30, the enthalpy of atomization of zinc is lowest. Why? Why is it lowest? Easy, students. Yes, remember, in case of from scandium to zinc, the enthalpy of atomization, what is happening, students? Yes. First of all, whenever you're talking about enthalpy of the atomization, write the configuration. Scandium D1 configuration, zinc D10 configuration. So tell me, this is your 3D, this is your 3D series. So what will happen? In this case, all are paired in between 3d5. When it is paired, what will happen, students? No metallic bonding. Means basically it will not form. Metallic bonding is this. So when there is no metallic bonding, or no electrons rather, no electrons are there to bond, no? So what is going to happen? What is going to happen? When there is no metallic bonding, enthalpy of atomization will be less, because I can apply less energy to break it. But in this case, in all the cases from here till here, you have strong metallic bond. So enthalpy of atomization will be more. For zinc, it is less because there is no metallic bond. Done. Next question. Explain why copper plus ion is not stable in aqueous solution. Okay, done. Easy questions. Just see. So basically, one thing you write. In aqueous solution, write your answer like this. In aqueous solution, what is going to happen? Cu plus 2 is more stable than Cu plus 1. What is the reason? Because here I have to apply certain energy. Yes. What is that? Hydration enthalpy. Okay. What is that? I have to apply certain energy called hydration energy to what? To take out one electron. Yes. Yes. I have to take out from here. Check carefully. From Cu plus 1, what am I doing? I am taking out one electron and becoming Cu plus 2. So, to take out one electron, this hydration enthalpy used or applied. So, I'll write again here. Hydration enthalpy is very, very high. Very high. Very high. So, to pull out one electron. So, what to do? It will become unstable. That's why Cu plus 1 is unstable. Hydration enthalpy is very much. So in aqueous solution, what will happen? Because I am applying so much energy to pull out, it is unstable. So to compensate this, what is going to happen, students? Cu plus 1 will undergo disproportionation reaction. It will undergo disproportionation reaction. It will form both oxidation reduction, and it will become stable. So this proportionates to form Cu plus 2. This proportionates to form Cu plus 2. So that it becomes stable. That's okay. So you're going to write this answer for that. Next comes your 3 marks questions. Very quickly we'll answer. Okay. Although Cu plus 1 has configuration 3d10 for a 0, Cu plus 2 has configuration 3d9. Still, Cu plus 2 compounds are more stable than Cu plus. So they are saying Cu plus has 3d10 configuration, Cu plus 2 has 3d9 configuration, but Cu plus 2 are more stable than Cu plus. Why they are asking? Why they are asking? Now, remember students, check carefully, understand. In aqueous solution, most important thing just now we have discussed. Cu plus is less stable. Yes, in Cu plus 2 is more stable. What is the reason, students? What is the reason when I compare? In Cu plus, hydration enthalpy is more. It is more. So, what to do? What to do? Because of this hydration enthalpy overpowers the second ionization enthalpy. So, what is the concept here? Hydration enthalpy overpowers second ionization enthalpy. That's why Cu plus compared to Cu plus 2. Okay, yes, so the configurations are same. Cu plus is more stable than Cu plus 2 because hydration enthalpy is more than the ionization enthalpy. So I will discard that and undergo disproportionation reaction and become stable. Yes, so this will undergo disproportionation reaction and become stable. Next, titanium 4 is more stable than Ti plus 3 and Ti plus 2. Titanium 22 after scandium. This is 3d2, 4s2. Now Ti plus 3. It will become 3d1, 4s0. This is Ti plus 2. This becomes 3d2. So when I make Ti plus 4, what will it become? It will become 3d0. So 3d0 is what means before this what is there? Inert configuration is there, inert gas is there, na student? That's nothing but argon. So this is the most stable configuration. Done. Now check. That's the reason T4 is more stable than Ti plus 2 and Ti plus 3. Got it, students? Yes. Easy. Check it. Done. Next question. Why is Cr plus 2 reducing and Mn plus 3 oxidizing when both have D4 configuration? Simple. Understand carefully. So, Cr plus 2 means what? They said it is reducing. Okay. When something says reducing means what are we doing? It is losing electrons. Done. So Cr plus 2, what is its configuration? It is D4 configuration. Done. Now, what will it do? It is going to lose one electron. It will become D3 configuration. When it is D3 configuration, so what is it becoming? It is gets oxidized. Loss of electron is getting reduced, itself gets oxidized. Done. So from D4 it is becoming D3. Now what is this configuration? This is nothing but Cr plus 3. Now you only tell D3 is most stable T2G set. Most stable T2G set. Correct now? How does it look? It looks like this. Yes. This is like this. How much is there? D3. 1, 2, 3. This is T2G. This is EG. So how will it split? It will split into two parts. One is T2G, 1, 2, 3, one is EG, done. So here what is happening? Yes, in case of Cr plus 2, careful, it is trying to convert into D4 to D3 and forming stable T2G. That's why it is trying to act as a reducing agent. Let us talk about manganese now. Okay, I don't have place, I'll write here. What is happening in manganese? Manganese, it is getting converted from D4 to D5. Yes, so Mn plus 3 is D4 configuration, Mn plus 2 is D5 configuration, Mn plus 2. So what will it do? It will get converted to Mn plus 2 by gaining electron. When something is gaining electron, which agent is this? It is oxidizing agent. What it students? That means Mn plus 3 will become Mn plus 2, Cr plus 2 will become Cr plus 3. Cr I'll write here. Cr plus 2 will get converted to Cr plus 3. Mn plus 2 will get converted to Mn plus 3. This is nothing but your losing electrons, reducing agent, gaining electron, oxidizing agent. Done. Perfect answer. Correct. Next question. Highest oxidation state is highest manganese fluoride is Mn4, whereas highest oxide is Mn2O7. Simple. I told my students. Yes. So the ability of oxygen. So here what is important? Oxygen is having higher oxidation state. What answer I will write? I will write ability of oxygen to form multiple bonds with metals shows the higher oxidation state. Shows the higher oxidation state with metal. That means it is more stable. It is more stable. Got it, students? It is more stable. Perfect. That is all. So that's why it tries to form higher oxidation state and make itself stable. Done. Next. Copper cannot liberate hydrogen from dilute acids. What? Though only oxidizing agents like nitric acid, concentrated sulfuric acid react with copper. What is the reason? So understand the question. Remember, whenever I talk about copper, yes, this copper, when it is losing Cu plus 2 aqueous state, right, I am applying, right? So basically to take out 2 electrons, what is required? High hydration enthalpy. It requires high hydration enthalpy. What is doing? High hydration enthalpy. Now, this hydration enthalpy, because of this, the electrode potential value is plus 0.34 volts. Done. Now, this value, when you see your electrochemical series, students, electrochemical series, you very well know plus 0.34. Positive values are above, correct? Yes. So positive values are below and negative values are above in the electrochemical series. It is like this now. Your hydrogen is here, all your values are here. So what will happen? Copper value is positive value which lies here. Done. So because it lies below your hydrogen, what is going to happen, students? Copper cannot liberate hydrogen from acids because it lies below in the electrochemical series. Then next question. A metal which is strongly attracted by magnet is attacked slowly by HCl, liberating a gas. Students, let me drink some water. And producing blue color solution. The addition of water to the solution causes it to pink. The metal is simple, students. A metal is strongly attracted by a magnet and is attacked slowly by an acid. The metal, whatever is there, metal is CO. Done. So this CO combines with HCl, it gives COCl2 plus hydrogen gas with HCl, 2 moles. This is a blue color solution. Now what did I do? I have taken the addition of water into the solution causes it to turn pink. Okay. Now I'm going to add some water to this. This being the metal, it's going to form a complex. This is your complex. Plus 2. This is blue in color, this is pink in color because of water of crystallization. Because of water of crystallization. Got it, students? Easy? Check. Done. Next, comment on the statement that elements of the first transition series possess many properties different from those of a heavier metal. So, what are the properties which will make the first transition series has many properties compared to the others? Like 3D series has more properties compared to 4D, 5D, 6D, like that. What are the reasons they're asking? Chalo, I have placed in the next page. Let me take first. First of all, when I check the 3D series, remember ionization enthalpies of heavier metals. Okay, the other metals after 3D, na 4D, 4 whatever heavier metals, whatever are there, are very high. Because of this, I can't put out more electrons very high than 3D series, right? Second, other transition elements, heavier metals are no? Other transition elements, because they can't give out electrons, what will happen? Other transition elements are less reactive than 3D. What is 3D? Yes, 3D elements. Okay, one more reason. Yes, melting point of other means heavy transition elements. I'm writing TM for transition elements are higher than 3D melting point. Then higher oxidation states weighted take higher oxidation states of TM transition, other transition elements, other transition elements, mean heavier transition elements are less stable compared to, this is less stable, stability order, less stable compared to lower oxidation state of 3D. They're less stable. That's the reason they don't prefer. Check. Easy. If you write these 4 points, that's more than enough for the examiner. Done. Next question. The paramagnetic character is in 3D series elements increases up to manganese and then decreases. So paramagnetic character increases. Now see student, I'm taking a 3D series. It starts with scandium atomic number 21. It reaches manganese atomic number 25 and then it ends at zinc atomic number 30. Here the configuration is 3D10. Here the configuration is 3D5. Here the configuration is basically 3D1, 3D2, 3D3. Check. Here in this 3D5 configuration, what will happen, students? Here you have one unpaired electron. When I come here, gradually, slowly, from 3D6, 3D7, 3D8, 3D9, like that, what is going to happen? After manganese, pairing starts. When pairing starts, what is important? Diamagnetism increases. Diamagnetism, magnetic property, it starts increasing. Correct? So, what am I trying to tell you is, in 3D series, yes, from here till here, paramagnetic property because of unpaired electrons, paramagnetic. From here till here, it is diamagnetic property because of pairing. So simple, write like that. So from D1 to D5. It is paramagnetic. D5 to D10. They are diamagnetic. Means diamagnetism starts. Diamagnetic. That is what you can write. Next question. Why do Mn plus 2 compounds more stable than Fe plus 2 compounds towards oxidation state to plus 3? Okay, understand. Mn plus 2 compounds are more stable than Fe plus 2. Okay, careful. Let us write Mn plus 2. What is the configuration? Argon 3d5. Done. In this, all the electrons, whatever are there, are singly occupied. Done. So, this is a stable electronic configuration. Stable electronic configuration. Done. Now, if I want to lose more electrons from this, what will happen, students? I require high energy. High energy. High energy means the molecule becomes unstable. Correct, na? The molecule becomes unstable if you're using high energy. So to take out one electron, you'll use, first of all, this is stable configuration. Stable configuration. So high energy is used to become unstable. So Mn plus 3 not preferred. Not preferred. I can't take Mn plus 3 from here. Done. If I want to take Fe plus 2. So can I write in the next page? Sorry for this. But when I took Fe plus 2, check. Configuration is argon 3d6. What will it do? It will lose one electron. And it will become argon 3d5. So Fe plus 3 easy. Okay, with less energy, less energy, Fe plus 2, it is becoming Fe plus 3 and this is stable. That's why this is preferred. Fe plus 2 to Fe plus 3 is preferred, but Mn plus 2 to Mn plus 3 is not preferred. Next 5 marks questions. Let us see the 5 marks questions, students. Okay. Among lanthanides, cerium plus 3 is easily oxidized to cerium plus 2 plus 4. Why? Let us put it in one sentence. Yes. Now, check carefully, students. First important thing, cerium plus 3 is oxidized to cerium plus 2 means, concept number 1, lanthanides. Cerium from plus 3, it is going to plus 4 because of what? Presence of due to vacant N-2F subshells in Ce, where N-2 subshells in Ce plus 4. That's why it is losing one electron. Done. Next. This is what is important. Next question. Fe plus 3 by plus 2 redox couple is less positive than Mn plus 3 plus Mn plus 2. Simple, I said na. Fe plus 3, just now I've explained, see students. Fe plus 2 to plus 3, it is gaining stability, correct? So extra stability of Fe plus 3 compared to, just now we have explained, compared to Mn plus, just now I have explained here, plus 3 compared to Mn plus 3. Done. Third question. Second transition elements and third transition elements have almost similar atomic radii due to lanthanide contraction. Done. Easy. Next. Do I have place? Yes, I have place. The fourth point I forgot. Sorry. What is the question? Transition metals and many of their compounds have paramagnetic behavior. Why? Okay. I said no. Paramagnetic behavior is what? Always remember, paramagnetic behavior means it is always, remember, it is due to unpaired d electrons and dd transitions. Because of this unpaired d electrons and dd transitions, automatically Paramagnetic behavior is more in transition. In transition. Okay, students, done. Okay, next. Account for the following: zirconium and hafnium have similar properties. Answer simple: because of lanthanide contraction. Because of lanthanide contraction, what do they have? They have same size. Zirconium and hafnium have same size. So when the size is same, properties also will be similar. Properties will be similar. Got it? Next question. Zinc salts are white while copper salts are colored. Simple, students. Zinc has D10 configuration because this is paired. No DD transition. That's why these are white. In copper plus 2, there is one unpaired electron. Because of this one unpaired electron, you have DD transition and they are colored. Done. Next question. The transition elements have high enthalpies of atomization. I said earlier also, only one statement you won't write. More number of unpaid unpaid electrons. What is it? Maximum metallic bonding. When the bonding is maximum, remember that particular bond is strong metallic bonding. When the metallic bonding is strong, it is important, students. Yes, enthalpy of atomization delta AH is, that's all, easy. Next question. We have already discussed this question. Yes, in among transition elements, the highest oxidation state is exhibited in oxoanions. I said no. What is happening, students? In oxoanions, oxoanion means what? Oxygen atom is directly attached to the metal atom. Now, what is happening? This oxygen atom is more electronegative. So, what will it do? It will pull the electrons. When it pulls the electrons, it is going to form highest oxidation state. So that highest oxidation state, for example, is Mn2O7. That's why oxoanion being oxygen being electronegative, it's going to pull and form. So this is stable compound, na? Stable. That's it. So transition metals in highest you will be seeing oxygen based compounds. Next, Zn plus 2 salts are white while copper plus 2 salts are blue. Simple. Zn plus 2 ion has 3d10 configuration, same story. Cu plus 2 ion has 3d5 configuration. This is completely filled. Completely filled. This is stable. This is half filled. Done. So what will happen? DD transition happens. When DD transition happens, these salts are colored. Here, no DD transition. Yes, yes. That's why these are white. Done, students. Perfect. Now, check. That's it. The complete D block chapter in one shot. Done. So I assure you, you will be getting full marks with this, full marks. So please subscribe to the channel, like the video, share the video and comment. So I'll be coming back with part 3 video tomorrow. Bye, all the best. Please share the video to all your friends. Thank you so much for watching.